Welcome to my session on getting started with Entity Framework Core 2.0. Good morning, everyone. Good evening. I was just testing you to see if you are awake or not. Right? So before me getting started with the session, I'd just like to take a quick poll on how many of you are already using Entity Framework within your applications. Quite a few. And Entity Framework Core? Very less, okay. And how many of you haven't worked on any of the ORMs at all on .NET? ORMs. How many of you haven't worked on ORMs at all? Okay. There are quite a few people, right? So don't worry. So even if you're not aware of what exactly Entity Framework is all about, by end of this session, you would get to know how to use Entity Framework within your application, right? I can assure you that. And just a disclaimer that this is going to be a level 100 session. It's going to get more of an introduction about Entity Framework, the history of how things have evolved within Microsoft on the ORM front and what the state currently, right? And we're going to see some hands-on demo of building some things with Entity Framework Core. Just a quick introduction about me. Well, my name is Senthil Kumar. So I work for a company called Think Money Group, which is a UK-based bank financial firm in Manchester, and I'm a developer there, developer by passion and profession, and I'm a Microsoft MVP in Windows, Windows platform as well as Visual Studio Technologies, and I've also authored a book on building universal applications using your web development skills, HTML, CSS and JavaScript. Right? And if anyone wants to reach out to me, here are my coordinates, my Twitter handle @isenthil, and trust me, isenthil doesn't have anything to do with iPhone, so there is no trademark violations, right? It's just I am Senthil, so that's how it came, right? So, and I blog at developerpublish.com, where I frequently write about ORM, C#, Dapper and so on. And I'm also a regular speaker at various user groups and also at Microsoft DevCamps and WebCamps back in India. So I've just relocated to India last year, and this is my second talk in UK, right? So that's more about me, right? So in today's session, we're going to look at what exactly Entity Framework is all about, right? And then we're going to look into the different versions of Entity Framework that have come until now and what are the different frameworks that were there, and also a quick glance at what are the other possible ORMs that are there in the market, just a few list of items, right? And then we'll also see Entity Framework 6 in action, see what are things that were possible with Entity Framework 6, just a simple database first approach, and then we'll jump on to code first approach with Entity Framework Core, right? So is everyone okay? Is everyone all set? I don't see the energy. Yes. So what is Entity Framework? I'm sure most of you are already using it, right? It's a kind of ORM, object relational mapper. So it is one of the official data access technology for .NET development. So it's officially out of the box from Microsoft. So versions prior to Entity Framework Core, we did have Entity Framework, the full version being available as a part of your .NET stuff. So it all started with the first version of Entity Framework, which was released sometime in the year 2007-2008, which was part of the runtime within the .NET Framework tooling within Visual Studio. The same applied even with the next version of Entity Framework as well, which was named as Entity Framework 4. Note from 1 to 4. Fourth was the second version. And it was part of your .NET 3.5 Service Pack 1. So then there were new versions of Entity Framework, which is more like an update, which started with 4.1 to 4.3 and which also add Entity Framework 5. And most of this was different in the way that you're going to install and work with. out of the box, you did have Entity Framework as a base version, but then you always used to get it from NuGet. Whenever you wanted an update of packages, it's always via NuGet. And then started the Entity Framework 6 and 6.1, and then 6.1.2, which is again add a lot of new features being added, something like asynchronous functions and stuff and so on. So I've personally worked from Entity Framework 1.0 till Entity Framework 6. I had close to 4 to 5 years of experience working on the complete Entity Framework there. And now we are at this particular point of time where just slowly graduated into Entity Framework core now. It all started up with Visual Studio 2008, Service Pack 1, where the first version of Entity Framework was introduced. And within the first version of Entity Framework, we had this designer based support where you could use EDMX file, use database first approach, import the database, start writing the code, and your Visual Studio is automatically generate a lot of steps for you, generate the models for you. Right. Then came the Entity Framework version 4, which brought in a lot of changes. The first version of Entity Framework, a lot of developers were not happy. Right. So during that time, because most of the time it was more of a I would say not code first approach, but your Entity Framework 4 brought in that code first approach, which was a major transition from the way that Entity Framework worked from 1.0. Right. So before this Entity Framework, Microsoft had something called Link to SQL. How many of you have heard of this Link to SQL? Most of these guys, right? So what is the problem with Link to SQL? What is the problem with Link to SQL? Why it did not continue like the way Entity Framework was there? And any guess? But then it was completely deprecated. If you look at the way that investments gone on to Entity Framework, it was not the same thing with Link to SQL. Right? Link to SQL was a kind of ORM which Microsoft brought in initially, which was specially targeted at SQL Server. Right? It was working specially for SQL Server. But Entity Framework broke that barrier. Right? It is compatible with other providers like Oracle, where they have their own way of connecting your connecting to your database from your Entity Framework applications. Right? So that was one of the major selling point for Entity Framework. And your Link to SQL and Entity Framework was working based on the providers, which means there is a common interface which every provider, if they implement, they would be able to get into and use the Entity Framework features. Right? So if you look at ADO.NET, what is the major interface that is used for the connectivity? We had something called SQL connection, and we had something called SQL command. Those are classes, but it in turn extends from some interface. Right? Similarly, we had OLDB provider, OLDB command, OLDB connection, and so on. Even that had a common interface. Right? We had this interface called IDB connection. Right? So most of these functionalities have been put across an interface, right? And when that interface has been implemented by the providers, they could use these functionalities. Right? And with Visual Studio 2012 is what you got Entity Framework version 5 and Entity Framework version 6. And with version 6, that's when you add these features of asynchronous programming, where I could run the queries asynchronously, right? Which was a major performance boost for developers writing queries as well. So in simple terms, Entity Framework is a ORM. ORM stands for Object Relational Mapper. So what exactly is an ORM, and what does ORM does? In simple terms, a ORM reduces the friction between your database structure and the way that you're trying to access the data. Right? Pre-ORM, assume that there is no ORM. how do developers access the data? Write a SQL query, get the data from the database using a data set or using a data reader, read it one by one, assign it to the classes, and then bind whatever the objects that you have onto the front end, right? That was a standard process that most of the developers would have followed. I am sure even now a lot of people do that as well, right? So now, what does ORM do? It reduces your work of doing that conversion and getting the data back from the database. You have a model, what represents or what needs to be shown on the UI, right? And you work with that to get the data, instead you writing your queries manually. It completely reduces your friction between your database structure and the way that you access the data. So in simple terms, this is what Wikipedia says. It's a programming technique for converting data between incompatible system types such as DBMS, in relational database, and object-oriented programming languages. Just converting the data, you have your own conceptual schema, physical schema, convert that and get what you need without you doing lot of work. Instead of you reinventing the wheel again, it does most of the work for you, right? It does most of the plumbing work for you to aggregate, modify, save your data, perform all the CRUD operations that you want, create, update, delete, select what you want. So most of the things are done under the hood. So what are the other ORMs that are available for .NET developers? Dapper. Dapper is one of the popular ORMs, right? It all came from the Stack Overflow. Apart from Dapper, anything else? Yeah? NHibernate. NHibernate was one of the first ORMs that I started working with before even getting started with Entity Framework. It was such a massive popular ORM during that time, and it was a port of the project called Hibernate, which was generally used by the Java developers. And it used to work based on XML configuration stuffs, and that was so popular during that time. And Entity Framework was literally competing with NHibernate in terms of the feature parity. Right? Apart from this, anything else? Yeah? Subsonic, okay. Simple data, massive. So massive, simple data, Dapper are all micro ORMs, right? So if you have to look at this, I've just got few list. DevExpress has a commercial product called XPO, which is also a kind of ORM which developers can use, right? Dapper is one which is quite popular among most of the developers who look at performance as a priority, right? Petapoco, that's not the logo, I just wanted to get the text, but just got that logo there. And LLBL Gen Pro, which is again a commercial product, which is again an ORM, which is quite powerful one. We had .NET Tires and Tire Developer. They're all some of the ORMs which people tend to use and which is quite popular among the developers, right? But Dapper and Petapoco and Massive and so on, right? They are more of a micro ORMs which are completely different from the way the features are provided when you compare it with your actual ORMs like Entity Framework or NHibernate, right? But performance wise, yes, Dapper do overtake certain parameters against the other ORMs, but functionality wise your ORMs provides a lot of other things like your database level caching and your change tracking, for example, are all provided by your full ORMs, where Dapper lacks in certain areas of those functionalities. Anything else apart from this you guys have worked on? Obviously a link to SQL, which was very old. Apart from this, so under the hood, right, what does ORMs do? What does it use when especially working with the .NET? It all interacts with ADO.NET, right? ADO.NET is the ultimate library, or the classes provided by ADO.NET is what most of these ORMs tend to use. to connect to the database and perform whatever the manipulation that you want to do on the data. Right, when I say ADO.NET, I am referring to all those SQL DB command or OLDB command or whatever the other Oracle client and so on, right? All these are part of your ADO.NET. So ultimately under the hood, under the metal, it's more of ADO.NET, where ORMs interact with this, and ORM is more like one layer top of your database or one layer top of your ADO.NET. So in simple terms, Entity Framework is a ORM from Microsoft, and it's a data access framework. It provides data-centric applications and services. It enables you to program against the conceptual model or conceptual schema rather than working with the physical schema, without you worrying too much about your SQL queries and so on. And it enables independency of any data storage engine or relational schema. So it works with pretty much most of the different database providers, provided if they have support for the Entity Framework. So when working with the Entity Framework, starting from the version 6 or with the full-fledged version, there are basically two ways in which you can do things. Whether you're building an application from the beginning, from the scratch, that's with a new database, or you might already have a database and you wanted to work with the existing database, right? So that can be classified into two different approaches with Entity Framework 6 and previous versions. So one is a design centric and another is a code centric. So with the new database, what you do is you try to build the model, create the model in the Entity Framework Designer. You try to build the model and generate the database from the model and work on it. So if you have to have an existing database with the same designer centric, you're going to import the database into your Entity Framework Designer. All that it does is it does a reverse engineering. It just finds out what are the tables, what are the columns, stored procedures and so on, tries to do the reverse engineering and generates the models for you. And it provides a designer support where you could go and then play around with the designer and get things done. So your designer centric was one of the easiest way for someone to get started, especially for someone like a newbie developer who doesn't know how to work with the code first. Designer centric was always an easiest way to get started. And I learned Entity Framework beginning with designer centric. Then came the code centric part, which came into picture from Entity Framework 4, and that's when you actually start writing the code rather than using the designer by yourself. Whether it's a new database or whether it's an existing database, you play around with only your C# code. You know that you are proficient in C#, you just use that instead of using the EDMX or an Entity Framework Designer. So all that you do is define classes, do the mapping in your code and do the processing. Either you wanted to generate the migration scripts or a new scripts, you're going to do that manually there. And most of the code first approach, you're going to do it typically using C#. So you guys want to see a demo of Entity Framework 6? Yes? So I'm going to use a designer here to just show you how it works with Entity Framework 6, right? And we'll get into the code first approach when we get into the Entity Framework code, because it's almost, it might become repetitive if I'm trying to cover both in this particular area. So I'm using Visual Studio 2017. All that I'm going to do is now create a new console application to demonstrate the Entity Framework 6. How do I consume that in my console application? And Entity Framework 6 can be consumed in any full .NET framework application that you are using. For example, it could be a WPF, it could be a ASP.NET, MVC or web forms or your Windows applications, right? So in this case, I'm just creating a console application and selecting .NET 4.6.1, right? And it's just opened up a simple application and it has created the program.cs file. So now what I'm going to do is I've created a database and the database structure looks something like this, where I have a blog and I have a post, where the blog would contain the list of all the URLs, and your post would contain all the articles that have been part of your blog, right. There is one-to-many mapping there, right. So, your blog ID is a primary key here and your blog ID is a foreign key here. So, there is a one-to-many mappings between your blog to the post, right. What I am going to do is head back to Visual Studio, and is it visible to everyone? Yep. Yes? Cool. So, I am going to right click on the project and say add new item, and this is going to provide me a list of new item templates for me, and I am sure everyone would be aware of it. And I am going to select data on the left hand sidebar, and you are going to see ADO.NET entity data model here, right. So, I am going to pick that and then provide a name for the model. In this case, I am going to say it is more like DP, that is a developer publish, that is my website name. So, your I will give it as developer pub. So, this would be the name of your EDMX file, right. So, I click add. So, now it provides me an option to say, hey, what do you wanted to do, whether you wanted to create an empty designer model, or you wanted to write a code first from database, or you wanted to put up an empty code first model, or do you wanted to get the data from the database and then put it onto the designer. That is what your options are provided here. So, I am going to select EF designer from database and click next. So, now it is asking me to configure my database, asking me to provide me what is the connection, what is the database server, and so on. So, I am going to say /SQL Express, that is a local server that has been installed, and I am going to pick the database here. It says developer publish. Let me test the connection, and you submit and click OK. Right. So, it's added the connection, the SQL connection, and it's put into the app.config file, and this is more like your context. Context is nothing but your connection to the database. How do you interact with? So, this is one of the classes with which you will be able to do the interaction with your database. And I click next, and it says which version of entity framework do you want to use. I am going to pick 6.x, which is the latest version here, and click next. So, this is going to provide me with list of all the tables that are available, tables, views, stored procedures that are available within your database, and you can pick which one to use and generate the models accordingly. So, in this case I am going to pick blog and post and click next, finish. So, do you guys see the designer now? It is a EDMX file on the Solution Explorer. On the Solution Explorer, you should see a EDMX file created, which says developer pub.edmx, and when I double click on that is what you get this particular file here, which shows the tables that are being imported into your database, and this represents your C# class actually, right. This is more of your conceptual schema in this case. So, this is the conceptual schema that we are referring to. So, if you just expand this EDMX on the Solution Explorer, you are going to see blog.cs and post.cs. So, these are nothing but the models which represents your database table. So, when I double click on it, you are going to see what is the class and some of the properties which are available inside this. So, all these properties here are nothing but your columns inside the database. For example, ID is one of the columns, title is one of the columns, right. Blog ID is actually the foreign key to the blog table, right. And then we have this blog as one of the objects by itself. So, this is more like your navigation property in this case, right. I will come back to what exactly navigation property is. To just confirm if this is what our entity framework has generated, you should be able to see the same. You see ID, you see title, you see blog ID as well, right. So, and let me get on to Visual Studio. Similarly, it would have generated the same thing even for your blog.cs as well, right? Most of the things are automatically generated by your Visual Studio, right? And you have less control over this, the way it's been generated. But for a newbie developer, if I wanted to name the URL to something else, I can select URL here, and in the properties window, you should be able to see all the different properties which would be available for you. What is the data type that it's been mapped to? So it's currently string, because in the database it's more of a varchar, right? So now we got these models imported. So the models are generated by your Visual Studio. So the next step for us would be to go and then perform the basic CRUD operations on your database, right? So how do we do that? So let me go to program.cs. So like I mentioned, so the name of your just a second, let me just expand. So this extends from DB context. So DB context is one of the a major player for us to get the entity framework to work. So before entity framework 4, we had something called object context. So that was replaced by DB context with a lot of abstraction on top of that, right? And DB context is the way to do things now rather than object context. And DB context is carried forward to your entity framework core as well. So wherever the DB context, what are the things that you can do with DB context is pretty much you can do within your entity framework as well, right? So we're going to use this name to connect. We're going to create an instance of developer publish entities and then do whatever the manipulations that we wanted to do with the data. So in this case, I'm going to the program.cs and let me start creating an instance of the DB context entities. Right. And I've created an instance here, and let me just close it. So I'm using the using keyword, so it does the disposal once it comes out of the scope. So let's try to insert a record to the blogs table with the conceptual schema, right? So in this case, for us, the blogs table represents the blog class here, blog.cs. So all that I do is go and say blog equals to new blog, and let me provide some values to it. ID equals to 2 and URL equals to, so any blog name that you wanted to enter. Any favorite blog names? So I'll give msdn.com/blogs just for example, and I'm going to add. So all that we are trying to do is we are trying to insert a record into the database with this particular data with an ID of 2 and URL of msdn.com/blogs. So the next step for me is to put this into the context, right? So we have a context dot blogs. So in this case, blogs represents the actual DB set. When I say DB set, it's the collection of records from your data, right? So I'm going to add a blog inside this, and I'm going to say save changes. So let me say console.readline in the end so that stays here. So let me try to run the application. Hopefully it should add the record. Yes, it stopped. So let me get onto the database and see if the records have been added or not. So you see that new record is been added, right? All that you did was you already had a model within your project, just populate that and call the corresponding methods of your context, and most of the plumbing work is already taken care by your entity framework, right. This is one of the simple statements of using entity framework, right, one of the very basic stuff that we used to do. So, now coming back to the entity framework here and the model that we created, I mentioned about the DB set, right. So, if you go into the context and if you look at this particular piece of code, so one of the table is blogs and other one is posts, all the records would be fetched inside that if you wanted to show, right. And I can also go and then specify a different constraints on the model creating event here. So, what you see here is more of overridden method, but currently it's nothing is done in this case, but you will be able to go and then specify different constraints. We are going to look into that within next few more minutes, right. And your web the connection string is picked from your app.config file. If you see this name, it says developer published entities, and if you go to the app.config file, your Visual Studio has actually created an entry inside your app.config file with the connection string when you actually imported or did a reverse engineering of your database. So, if I go into program.cs, so now I wanted to fetch all the blogs URLs and display it on the console. So, there are different approaches which you can do, whether if someone is comfortable with lambda expressions or if someone is comfortable with the link queries, right. Link query is a language integrated query. So, you can use any of these two ways to get the data and display it, right. So, let us use a link query for the first step and display the result. So, what I am going to say is var result equals to, so your link query always starts with the from keyword and you say what is the record in the complete records that you have. In this case, the records that I am looking at is blogs, like blogs is nothing but a collection. Context.blogs will get me the complete set of records from the blogs table, and I can go and then say select record, and this is going to fetch me a list of records. So, I would be converting this to a to list, right. So, internally your entity framework, all that it does is it simply puts a select star from the blogs table and gets all the records, right. And if I need to display this on the output, I am going to say for each, since this is a collection, record in result console dot write line and say result dot record dot, I am going to say URL, right, as simple as that. So, now when I run, it is going to get me all the URLs that are available on the table. Yep. So, you should be able to see this. There are currently two records there, test.com and http://msdn.com/blogs, right. So, with the link you will still be able to put in all the queries like the way you do with your select where clause, right. You could go and then say, hey, go and get me an record with just ID of 1. In this case, I am going to say where record dot ID equals to 1, right. So, in this case, all that it does is it is going to go and then generate a select star from blogs table where record ID is equals to 1. That is what your entity framework is going to do internally. And when I run it, F5, just shows test.com, right, as simple as that. So, another way of doing the same thing is using link query, lambda expressions. So, lambda expressions is a new way of doing things which was introduced from .NET 3.0 onwards. So, all that you do is you say context dot blogs dot where and you specify the record ID where id equals to 1, and then you say to list. Simple as that. And when you run, you should be able to get just the first record still. Right? And your lambda expressions provides a lot of different extension methods. For example, you say select top 1 from the blocks table, you should be able to do that with lambda expressions or link as well. Right? So, in simple terms, most of this plumbing work is done by your entity framework. All that you focus on is writing a C# code, interacting like the way you do with a C# way, and everything is taken care by your entity framework. So, that is one of the reasons why your ORMs have been quite popular in doing a lot of your plumbing work for you. So, similarly, if you want to do a delete, it is almost the same. All that you do is context.blocks.remove and then call save changes. Until you call save changes, your records won't be persisted back to the database. Right? So, it is mandatory that you need to call the dot save changes method of your context. So, your tracking is actually updated back to the database. That is something that you have to keep in mind. So, this is all fine. So, entity framework 6, but so this Microsoft strategy has slightly changed after your .NET Framework 4.5 version onwards, right. So, they started working on something called .NET Core, right. So, how many of you heard of this name .NET Core? Everyone, or at least 70-80%. How about .NET Standard 2.0? Right. So, and .NET Native, right, quite a few. So, if you are from your UWP background or someone from a Windows Phone background, right, they would be aware of what exactly .NET Native is all about. It all started off with that, and Xamarin again, right. So, what are all these different terms? So, is .NET Standard a kind of another framework by itself? And how about .NET Core, .NET Native? So, your .NET Standard, right, is actually a kind of specification which says your framework that you are trying to use should follow these things as per your defined specification of .NET, right. It's like your ECMAScript and JavaScript. If someone says what is ECMAScript and what is JavaScript, you could clearly say ECMAScript is more like your standard or a specification which says any language that follows ECMAScript should have these features mandatorily available, right. And your JavaScript is one of the implementation of that. Similarly, you have JScript, which is again an implementation of your ECMAScript. So, ECMAScript is more like your standard or a specification. So, similarly, your .NET Standard is also kind of a standard or a specification. Your full .NET framework, which is more like your managed framework, right. And then we add this .NET Core, which is again a managed framework for you. Right. Similarly, there are so many other managed frameworks which are there. For example, Xamarin. Xamarin is also a managed framework which lets you to write C# applications which can run on both your iPhone or on your Android. That is the primary motive. So, it is still a managed framework for you, right. So, what .NET Standard says is there are a lot of functionalities which is common, which has to be followed as per the specification that is defined. Yes, it's more of a specification. So, initially we had these portable class libraries, right, which, so if PCLs are there, so why .NET specification in this case? So, it's a kind of overtaking now, because from the PCLs did have a lot of challenges. All that PCL does is, if I am on, for example, if I take Xamarin and I have Android application, I have an iPhone application, and I have another popular operating system Windows Phone application as well, right, all these three. So, now if I wanted to use a common code across all these three, your PCLs would shrink my ability to use all the APIs, Android and iOS might support certain things, but your Windows phone might not support. So it's like intersects all the features, and that is what your PCL provides to you. Right? And then they came up with something called a shared library as well, where you could use all the features, but you use compiler directives to achieve what are the features that you need to use in either of these features. Right? So your .NET specification, in this case, it's more like your .NET standard is more like a specification. It's not a new framework by itself. It's just a specification, the way that each and every managed framework should follow in terms of all the libraries that are commonly used. Right? And your entity framework core 2.0 is actually .NET standard 2.0 compliant. And what is entity framework core? It's a lightweight and extensible version of the popular entity framework data access technology. So it's when I mean lightweight, there are some specific reasons why it's called lightweight as well. I'll come back to that soon. And so what are the other possible challenges that you saw when you were using entity framework? The full version of entity framework. Performance, definitely yes. But again, performance also depends most of the time, although it's to do with the framework, but most of the time it's the developers who write the queries, right? Sometimes you just access something which is doing a lazy loading, your performance goes for a toss, right? It's also dependent on the developer, like the way they write the code as well, right? Apart from that, anything else that you guys see?
Deleting child objects. Deleting child objects.
Delete child objects, okay, but still that was still possible, right? But there were a workaround for that, but still it was possible. Batch updates, that was one of the interesting features, right? Batch updates with the entity framework 6 and previous, it was very difficult. There were few community work which was done, which I personally have used some of the projects from Codeplex to do batch updates, but out of the box it was very difficult to do a batch updates. Right? Batch updates was a challenge for me, right? Apart from that, if you looked at entity framework as a whole, right? If I were to use something for SQLite, if I were to use SQLite as a database, should I still need a full version of entity framework? What does your entity framework end of the day contain? It contains everything that is there for relational or not unrelational databases, everything on other features, transactional stuff, right? Your core libraries, everything is part of your entity framework library or the DLL, right? So if I were to use just a SQLite, which means that I am going to use the complete library which has been there, right? Your entity framework assembly is almost around 5 to 8 MB size. So, but for me, when I am using SQLite on, especially on a UWP app or something else, right, I don't need such a big size at all, a library assembly, right? How could I make things better? So, especially with .NET Core, when Microsoft started working on the .NET Core, it was more like, it was never a Windows component going forward, right? They say it's more of a cross-platform. It has to work on different platforms, it has to work on different operating systems as well. That's how the .NET Core evolves slowly, right? So in this case, I can run my same application or the reusable component built using .NET Core on either a phone or a tablet or on a desktop as well, on websites. There are different platforms here, right? On the phones, obviously, it doesn't really make sense for me to use such a huge size, because when the users download the app just for entity framework, it might be such a big one, right? So but your entity framework core is a complete rewrite of your existing code base. So it's not the same, just they're trying to bring in the feature parity and new features as well. So which is possible with the .NET Core and Entity Framework Core, right? So it's a lightweight and extensible version of the popular Entity Framework data access technology, and it's again from Microsoft. And so if you look at left hand side is what we saw, the different versions of Entity Framework, which is been there until now, and there is work on 6.2 as well currently. There is no estimated time as such when it's going to be out. But if you look at the entity framework core, it all started with 1.0 and 2.0, which is the current stable version, and 2.1 is something that is in work, right? And so I've used entity framework core 1.0 in one of my applications in the previous company where we used to work. I used to work for a travel company back in India where we used to build applications for our customers to book online travel, online tickets or hotel bookings, and we actually built a universal app. So we tried to use some of this as a prototype when 1.0 version of entity framework core was released. So that's how we got used to that particular version number. And like I mentioned, entity framework core is compliant with .NET Standard 2.0, and it's more of a cross-platform. And just keep in mind that entity framework core is not a replacement of your full version of entity framework. If someone comes and says, I need to upgrade my application from entity framework to entity framework core, you need to ask what is the reason, what is the use case, right? Because you might see a lot of functionalities or features which is missing in entity framework core, which is already there in your older version of a full version of entity framework, right? And it's not a direct update, and if you still wanted to stick with applications built for Windows component or Windows runtime, Windows operating system, you could still use your entity framework 6. If you are a developer who is trying to target something for a cross platform, you want to reuse stuffs for different platforms or different operating systems, or if you have some specific simple use case which you need to work with, right, entity framework core is definitely worth trying it out. But it's not a complete replacement for your full version of entity framework, right? Some of the core themes of .NET Core which is applicable to your entity framework core as well is it's a composable APIs. When I say composable API, everything is now NuGet package, right? You could download it from the NuGet manager, and if you I'll show you in the next slide what exactly the composable API is. All that it does is it has split everything into sub-assemblies, right? For example, if I am working on SQL Server, I know that I need all the logics that are related to relational databases and all the core entity framework stuffs I need, right? If I am working on SQL client or say SQLite, I don't need SQL related stuffs at all. I don't need relational data stuffs at all, right? I can keep it still lightweight in that case, right? So the amount of libraries that you're going to download depends purely on what are the functionalities that you're going to use. It's more like pay for what you use, right? What features you need, just download accordingly and use it instead of getting the complete assembly and using little feature out of the full assembly. You just download what is necessary for you, right? And with 2.0, the core 2.0, there is a little bit of feature gap which is been closed, but still there is a long way to go with respect to the entity framework core, and most of the stuffs are more of a reusable building blocks which you can use, and more importantly it's more of a cross platform. So that's the main target of .NET Core, which is being passed on to even the entity framework core as well, right? So coming back to the lean and composable framework via NuGet. So with entity framework 6, we had this EF assembly which is about 5 to 8 MB size. I'm not sure about the exact number, but that's something in that range, which contains the entire EF features, which also adds .SQL Server 2, right? There is an assembly or there is a functionality or a namespace which relates to even SQL Server as well. So which gets added in spite of you using a different database, which is really not necessary at all. But with EF7, the reason why I mentioned EF7 here is Entity Framework Core 1.0 was initially named as Entity Framework 7. Then it was renamed to 1.0 because it was overlapping with the version number to say that it's not a direct upgrade, it's a completely new framework by itself, right, or a new library in this case, right. So, in this case it's going to be delivered in small pieces and it contains all the small composable assemblies. We are going to see that in the next slide, and we are going to see some of the namespaces here which is specific for Windows Phone and Entity Framework Core, right. So, prerequisites, if someone wants to start with Entity Framework Core, it is not like available out of the box in your Visual Studio, where like the way we saw earlier, because that was out of the box, but this is more like you need the .NET Core 2.0 SDK installed on your machine. Even if you have Visual Studio 2017, you need to ensure that this particular .NET Core 2.0 is installed on your machine in order to access the Entity Framework Core functionalities, 2.0 functionalities. And ideally you either need a Visual Studio 2017 or Visual Studio 2015. There are some workarounds. I have seen some samples where they have tried with Visual Studio Code as well, using .NET CLI, which is a command line interface, to download all the NuGets for Entity Framework, and still you could use your Visual Studio Code to play around with. But I have personally not tried that, just want to make a disclaimer on that. And you need the latest versions of NuGet. So, in case if you are using Visual Studio 2015, you need at least version 3.6. If you are on 2017, you would have already had the latest versions of NuGet. So, these three are prerequisites before you actually start some development on the Entity Framework Core from the development environment perspective, right. So, it's a simple 3 to 4 step process for you in this case to get started with installing the Entity Framework Core. All that you do is either go to the NuGet's package manager interface or package manager console, and then just type in this command which says install package Microsoft Entity Framework Core .SQL Server, in case if you are working with SQL Server. If you are working on some other database, there will be other providers as well and other NuGets available for you, and you could install that, right. And so, this you need install package which is more like Microsoft Entity Framework Core tools. Apart from the SQL Server one, you need this to actually do the management of your database. So, for example, if you are creating the database for the first time and you wanted to generate the migration scripts, so and you add a new column into the your model, and later on you wanted to get that back to the database, you use the functionalities provided by your Entity Framework Core tools to do that. The next step is go and then create your model. Your model is nothing but the same thing that we saw earlier. Go and create a class which is a context which represents your DB context, right, and then you create your blogs and models representing your table, and you are pretty much done with creating the model, right. We'll get into this when we look into the code now in some time, right. So, the third step is to go and then create your database. Like the way I mentioned in the previous slide, we also install something called core tools as well, right. The second step that we saw here, this step here, the package Entity Framework Core tools. So, this is actually used to do some of these functionalities, to run the migration script and update database, to actually put the changes of your model back to the database. Whether you wanted to create a new database or update the existing database is what you are going to do with this. And finally, you are going to access your model or a conceptual schema using your context like we saw earlier. Just create a blog instance of a blog or an instance of a post, call save changes method, and it's pretty much done for you, right. And so, in case if you are this is more like your code first approach. In this case, you have your own model, you are writing your C# code first, and then you are generating the database, right. So, assume that you already have an existing database and you wanted to generate the model out of it, right, and play around with it. So, we have this concept of scaffolding in .NET or in general programming terms. All that it does is it just creates all the potboiler codes for you. It just all that you do is just call this method with in the package manager console, which is part of your core tools, and this is going to generate the scaffolding or the necessary models from the database. It's going to re-engineer stuffs for you and then create models for you from the database. Right, so let's quickly see what exactly Entity Framework Core and how to use that within your application. So how do I get the Entity Framework Core libraries into my project? So like I mentioned, it's going to be via NuGet package manager, right? So I say right click and go to manage NuGet packages. It's going to open up. So is it visible? A little bit. Yeah. I'm going to go click on the browse and I'm going to say search Microsoft Entity Framework Core. I want to see a lot of different libraries available with the same name from different providers, but wherever you see this .NET symbol, you can assume that's from Microsoft and that's what you need to download. So this forms the core library for you, but there are libraries which are available specific to a particular database as well. For example, in this case, if I'm using SQL Server, right, there is a SQL Server version as well which says SQL Server. So when I search for it, it's going to display the NuGet here package, and if you look at this particular dependencies, you're going to see it requires Microsoft Entity Framework Core.relational, right? Because your SQL Server is a relational database, your SQL Server NuGet refers Entity Framework Core relational. So when you install this, it's going to download this as well. So let me just go for this particular library, and when I search for it, you will see that your relational in turn requires your Entity Framework Core greater than 2.0 version as well, right. So along with the other stuffs like your C# version number and .NET Standard version 2.0 and so on, right. It just downloads only the necessary libraries for you instead of downloading everything at one bunch like the way we had with the out of box. So in this case, if I say SQL Server, it's going to say, okay, this is SQL Server, there is relational and relational requires core, I need only these three for me to get started. So if I use say some other database which is like a non-relational database, I am not going to have the dependency on this relational package at all. So which means that that's going to reduce little bit of size for me when I am using it, right. So that's one of the ways. So the other way of installing is I can simply go and then say install, which is going to install this particular stuff for me, right. So the other way of installing is say tools, NuGet package manager and console, and I can go and then install the package by its name, right. So I can say install -package and I can specify Microsoft .entity framework core .SQL Server. I am assuming this is the name. Hope it's searching the library, gather dependencies. So another advantage of using the Entity Framework Core or your .NET Core is the libraries of your .NET Core is dependent on your project, which means that there could be applications on the machine which is using different versions of your .NET Core versions, right. Your library is actually specific, your runtime is actually specific to your project in this case. It's more of a private in this case. So it has installed the library packages, and if you see the references, you should be able to see the related items. Apart from the Entity Framework one, the first 4 ones are very specific to the Entity Framework, right. If I had SQLite, which means I wouldn't have had anything that you see here, it would be like very light version again, that is very specific to the SQLite, right. So let me just go back. Minus. So the next step for me would be to go and then create the model, right. I have already installed the package now. I need to go and then create a model. The first thing that I'm going to do is, as a best practice, I'm going to create a new class file and say class, and this I'm going to name this more like blog in this case, public class, and I could start defining the properties for my model which would actually represent my table as well, right. So, I would say int id. So, note I have given it more like id. So, this could also be more like a blog id for me. Could say blog id. The next model I am going to create is public class, and I say post, and I would specify a property which says int id, and I say next one would be string title, and I could also go ahead and specify int blog id, right. So, additionally I can also specify the navigation properties between my blog and the post. So, what it says is, if I have a blog object, I can go and then fetch all the records of my posts that are related to the blog, right. So, what I am going to do is prop, I am going to say list, it is a list of posts, right, and in this case it is going to be property and it is going to be of block type. Right. So, now I've defined my models now. So, the next step for me is to go and then define what is the entity or the context that my blog would contain, or my model would contain, or my schema would contain in this case. So, it is going to be public class, and like I mentioned earlier, your going to mention it more like your blog context, and this has to extend from DB context, that is a base class which is responsible for all the work to be done. DB and just import the namespace that are necessary, which is part of the core, and next you can specify what are the different DB sets or things that needs to be part of your object graph. So, in this case I am going to say prop, it is going to be DB set and say blog, and it is going to be blogs, prop, and you say DB set and say post, and say post, right. So, this defines all the DB sets, and so now if I create a context, right, I also need to specify now what is the database that you are trying to use and what is the connection string that it refers to. That is something that you need to specify for your context, right. So, override, there is an overrideable method which says on configuration. So, this is the place where you gonna go and then specify my library actually uses this particular database type, right, and then you could define what is the connection string that it needs to access. So, in this case I am going to go and then specify options builder dot, you see this when I say let me zoom in, so it is easier to see. When I say options builder dot use, it also has a extension method called use SQL server. So this is actually coming from the SQL Server library which we install the package, right? And this is more of an extension method. If at all it is a different database, you're going to see a different extension method for that instead of use SQL Server. And then I could go and then specify the connection string for this. Right, whether you wanted to get it from the config file or whether you wanted to configure it, you will be able to define the connection string here, right. So now apart from this, I can also go and then specify, let me override the method. I can configure by model with different properties. For example, if you wanted to apply a constraint, say you wanted to say there is a required field, I need this property to be mandatory, right, or this particular property should have a string length of say 30 characters, right, which is like varchar of 30, varchar of 50. You want to specify that as a part of your model as well. So you could do that with two different approaches. One is with a Fluent API or with data annotations. Data annotations is something that most of the developers will be aware of. All that you do is put an attribute on top of your property to say, so this is what I need. Say required, which means that your blog ID is a mandatory field in this case. So I can go and then specify that title should be of maximum length and of 100. So this represents varchar of 100 for me in the database. Right, so I can go and then define my constraints on each and every property or on the class level as well. So sometimes if you want your table name to be created in a different name rather than say blog, right, you can also go and then specify that with annotations. You say table and you could specify what is the table name there. So you have various annotations for that. So the annotations is one of the way. The other way that you can do is with your Fluent API. Fluent API you could go and then configure something like this, where you could go and then say override on model creating. When the model is getting created, all that you do is go and then specify model builder dot entity and you say blog, in this case say a dot, and then you can go and then specify different steps for you in this case, and then I can always say this as well, say just ignore this particular type itself rather than saying for each column. I can say completely ignore the table or columns and so on. So I will be able to go and then specify different constraints with one of the approach is using Fluent APIs. Right, so I can show you some examples here. So this is an example of, okay, so I want to show another demo, right. Sometimes when you are working with your context, right, you might want to put up actual SQL, communicate with your database with the SQL rather than depending completely on your entity framework, right. So now if you look at this, there is an extension method to do that with entity framework core. So I say context equals to new context, come on, new block context, and you say context dot and blogs dot SQL. I think there is an extension method, use SQL. Just a second, let me just get on to the right. I want to just show you an example with an existing sample here. So, this is what I meant using a Fluent API to say specify a property to say that is actually required, right. So, I can also go and then specify another property to say as maximum length. Instead of me specifying it on the annotations, I can use a Fluent API to specify this takes a character of 200. In this case, the length of this particular property value would be 200. You could go and then use your Fluent API or data annotations, which overrides your convention based mechanism to your configuration mechanism, and in this case your Fluent API will override even whatever you put on top of your annotations. So, that would take the priority in this case. There are two approaches, one is a Fluent API and other one is more of your data annotations. You can do pretty much everything with both of this. There are few things which cannot be done with your data annotations, which could be achieved with your Fluent API. For example, if you wanted to add an index for your model to say these two columns would form an index, it's much easier to do with a Fluent API than adding it to data annotations. And some of the supported scenarios, well, it's a big list here, a big description I would say. Your .NET Core implementation, you could use Entity Framework is fully supported on .NET Core, which means it can work on ASP.NET Core or .NET Core Console. Both would work provided if you have the right version of SDK installed as well for development. On .NET Framework, full framework, it's fully supported as well. You could still use your Entity Framework core on full version of .NET Framework. Mono and Xamarin, it is still in progress. It's not fully there, but still you could go and then still give a try and use them on your Xamarin application, right. And Universal Windows Platform, it's the same state like your Mono and Xamarin. Still in progress, there are still some known issues which you might have to overcome with it, but it's still there. So, like I mentioned, the lazy loading is one of the major things which is still not there in the Entity Framework core. So, what Entity Framework core is doing, it's just a lightweight extensible version of Entity Framework. Pretty much it provides most of the basic features what you need to build a line of business application or application which involves CRUD operations, and it's not a micro ORM. It's not the same as Dapper, but it does provide more features than what Dapper could provide as well. And there are already people who are trying to do the performance comparison between your Dapper as well as Entity Framework core, and result looks almost positive with most of the scenarios. And it supports relational and non-relational stores. And another feature which I just forgot to mention, which Entity Framework Core 2.0 provides recently, is seeding the data, right. Sometimes when you wanted to play around with some dummy data, just add some data and then test around with it, you could use a seed extension method in Entity Framework Core, which was very difficult to achieve with the previous versions of Entity Framework. So, seeding is one of the cool features. And design principles, it tries to keep most of the Entity Framework 6 patterns, like using a DB context, DB sets. I want to go and then use all the stuffs in which I want to load the data, and paper play is another one. You just install the libraries that you actually need rather than having the complete big library being used, and it is extensible as well, and you can use as when you need. Like I mentioned, what happens to Entity Framework 6 apps, it is not mandatory to migrate from Entity Framework 6 to Entity Framework Core, because there are different use cases. It depends on individual circumstances, and if you are looking at migrating, you might not find all the features which is already there, and you might find some breaking changes as well, right. Upgrade is a key scenario in this case. It depends on what you are trying to achieve, but most of the patterns or the way that you try to do things with Entity Framework is still same with the Entity Framework Core as well, right. Your learning on your Entity Framework is still carry forwarded to your Entity Framework Core. And some of the resources, just go to docs.microsoft.com/ef/core. That's the primary website where you see the documentation. about entity framework. You still see some of the pieces missing in the documentation, but it's more of a community driven. So in case if you want to contribute, go and then do the contribution as well. And your entity framework core is also available in GitHub. The URL is here, and some of the other blog links and demos where you could find on entity framework stuff. So this sums up my session on entity framework core. So I hope you guys would have got some idea about what exactly entity framework core is, how to use within your .NET applications.
Okay. Okay, thank you, Senthil.
Thank you.
Thank you.